So this, again, we're doing implicit differentiation, but now when we look at our terms, we've got x's and y's in the same term. So again, I'm just going to lay it out with lots of space underneath each one so that you can see me differentiate. I'm also going to fix that y, so now it's y to the minus 1. So differentiating each term here, when I differentiate this with respect to x, essentially the y squared acts as a coefficient. So when I differentiate this with respect to x, I will just get 4y squared. But because there's a y there, I also need to differentiate it with respect to y. So I will have my dy by dx, and again, the x will act like a coefficient. So I will times down by the power and get 8x, and then reduce the power by 1 and get y. Then for this term here, again, I'm going to differentiate with respect to x first. So it will be times down by the power, 12. Keep my y to the minus 1 because that's just a coefficient at this point. Reduce the power by 1. Then I'm going to differentiate with respect to y, which of course means multiplying by dy by dx because otherwise it doesn't cancel out. So multiplied down by the power, so I've got a negative 1, I've got my 6, I've got my x squared, and then reduce the power by 1, y to the minus 2, and then when I differentiate 10, because there's that implicit x to the power 0, that becomes 0. Then I'm going to go through and just tidy up. 4y squared plus dy by dx, 8xy, plus 12y to the minus 1x, minus dy by dx, 6x squared y squared equals 0. And again, as before, I would rearrange to make dy by dx the subject to finish it off.